Hi, welcome to the sneak peek for DIC101. In this short video, we are going to go over what you can expect if you sign up for this course. This course was developed by the International Digital Image Correlation Society, and it follows everything that is described in the Good Practices Guide for DIC. DIC 101 focuses on practical applications of DIC rather than theory or the algorithms. So we treat the software much like a black box, but we're going to show you everything about how to set up the equipment and how to process images once you have collected them. Our target audience includes both new practitioners to supplement vendor-based or other types of formal training, as well as experienced users to help refresh their fundamental knowledge, assist in troubleshooting, and align their practices with the larger DIC community. Additionally, anyone preparing to take Level 1 certification exam is strongly recommended to first take this refresher course, as everything that is covered in the exam is covered in this course. Our course instructors include myself, Elizabeth Jones, as well as my colleague Amanda Jones, both of us at Sandia National Laboratories. So the course format is comprised of two sections. First is 4.5 hours of videos, and in these videos we will present material from the Good Practices Guide as a narrated slide deck, similar to what you're seeing right now. In these narrations, we will have additional explanation, illustrations, and examples that help to illustrate some of the concepts that are contained in the Good Practices Guide. Then we also have laboratory demonstrations to really help elucidate the concepts that we talk about in the slides. And finally, these videos you can watch at your leisure at iDICs.org after you have signed up and paid for the course. The second section is the live Q&A sessions. We plan on hosting 3 or 4 of these a year, and you can go to the next one that's available after you sign up for the course. This will give you an opportunity to ask a panel of experts all of your questions, both about the videos that you've watched, as well as any specific questions for your DIC measurement setup. And lastly, I just want to reemphasize that this entire course is based on the Good Practices Guide, and the Good Practices Guide itself is freely available, so please go download that now. In the first chapter of this course, we will introduce digital image correlation and go over some of the main concepts at a very high level for both 2D and stereo DIC. Then we'll discuss the development of the Good Practices Guide, and this is really to show you guys the credibility of the guide and thus the credibility for this course. If you want some more information right now on the development and the credibility of the guide, please download the guide itself and you'll find all of that information in the front matter. In Chapter 2, we'll go over the design for your DIC measurements, and we'll start off with measurement requirements. We'll first talk about how to determine your quantity of interest, your region of interest, and your field of view. We'll discuss pros and cons of 2D DIC versus stereo DIC and how to select the appropriate one for your measurements. We'll talk about designing the appropriate position envelope for all of your hardware, spatial gradients and noise floor of your quantity of interest, what frame rate you might want to use for different types of tests, and also exposure time and synchronization and triggering. After we go over all of these concepts in the narrated slides, we'll have a demonstration that hopefully illustrates and elucidates all of these concepts. Now I want to give you an idea of what the demonstrations look like. We have a setup shown here, which is comprised of a rubber sample with a hole in the middle that is mounted into a manually cranked load frame. Then we have 2 cameras looking at the specimen for stereo DIC. We'll show either a side view, like you see here, or a top-down view, depending on which view is more illustrative for the concept that we are currently discussing. In addition to these overhead views, we also have insets that show live views from the 2 DIC cameras. In this way, at the same time, you can see that we are changing different aspects of the setup, for instance, moving the cameras apart, changing the lenses, things like that. And you can also see the effect that those changes on the physical setup have on the actual DIC images. Okay, now that you have an idea of what the demonstrations look like, I'll continue with the rest of the course outline. The second part of Chapter 2 is focused on equipment and hardware. Here we'll talk about lens selection, including the trade-off between focal length, standoff distance, and field of view. We'll discuss camera selection, mounting systems, and recommended camera orientations. Then we'll discuss lens aperture and specifically the interplay between lighting, exposure, gain, and your final image contrast. We'll also discuss different schemes for good lighting conditions, including cross-polarized and diffuse light, and then we'll discuss heat waves and how hardware heating can affect your DIC measurements. After we go over all of those concepts in the slides, we'll have 3 different demonstrations that again help to elucidate those comments with the actual exemplar that I showed previously. The last section of Chapter 2 is focused on the DIC pattern itself. We'll first briefly describe natural versus applied patterns, and then we'll go through a list of characteristics that you need to have for any good DIC pattern, including the appropriate size for your pattern, variation, density, quality, reflections, compliance, bonding, fidelity, and thickness. And then finally, we will briefly discuss some methods of creating different DIC patterns, but we'll leave an in-depth analysis of these methods for a separate course. Chapter 3 then moves from design of your measurements to preparation for the measurements in the actual laboratory. And here we'll first talk about your pre-calibration routine, including going over the overall test procedure, checking the cleanliness of your equipment, discussing camera warm-up time, synchronization of your cameras, both from one camera to the other for stereo DIC, as well as between your DIC measurements and your other DAC systems, and then an overall review of your system. Here we have 2 different demonstrations. The first is a very quick one focusing on cleanliness of equipment, but then the second one goes through the entire review of the system that you want to do before starting your DIC measurements. The next section of Chapter 3 focuses on the very important topic of calibration. Here we will go over intrinsic and extrinsic parameters, including lens distortions. We'll describe different types of calibration targets that can be used and what we mean when we say the volume to calibrate. And then we have a really fun game show that's called What's Wrong with My Calibration? And here we are going to go through different bad calibration images and bad calibration results and hopefully describe to you what's happening so that if you see any of these bad images or bad results in your own DIC measurements, you'll have a better idea of what's wrong and how to fix it. Then we'll go over different aspects of verification of calibration, including lens distortions, absolute lengths and distances, noise floor, and the epipolar error. And then finally, we wrap up with our last demonstration of the course where we show the entire calibration process. In Chapter 4, we talk about actually executing the test. Here, it's very application specific, and so we don't go into much details, but we will give some general comments on how to review all data acquisition systems, and then we go ahead and let you actually execute the test in your own laboratory. Chapter 5 focuses on processing the DIC images after you've collected them during your test. We'll talk about DIC software, and we'll point you towards the iDICs website and the resources page for more information about different software that's available. And then we'll go over user-defined settings. We'll first describe what the settings are and give you the rules of thumb for them, and then we will use the freely available and fully vetted images from the DIC challenge to illustrate the effect that the different settings have on your DIC results. Specifically, we will talk about the reference image, image pre-filtering, matching criterion, subset shape function, interpolation, and step size and subset size. And then lastly, we'll talk about different thresholds that might be available in your software for determining if the correlation is good or not. In the second part of Chapter 5, we will focus on strain calculations, since strain is one of the most common quantities of interest for DIC. And within this framework, we will discuss concepts for uncertainty quantification. Specifically, we'll discuss how to select an appropriate coordinate system for your test, what the virtual strain gauge size is and how to calculate that, and then we will go into detail about variance versus bias errors, and we'll do that through a complete virtual strain gauge size study. And in this VSG study, we'll describe how all of the user-defined settings that we described previously will affect your final strain calculations. Finally, in Chapter 6, we will describe the reporting requirements and talk about what information you need to include for any documentation of your DIC measurements. And just briefly, these will cover things such as all of the hardware parameters for the actual setup that you used, as well as all of the analysis parameters. Okay, that's all we have for this sneak peek of DIC 101. Hopefully that gives you a better idea of what is included in the course, and we look forward to seeing you sign up and talking to you in the next live question and answer session. Thank you.